Okay, good morning, everybody. I hope I'm audible to all. Can I have a confirmation, guys? Let me have a check also on my end. Yeah. Okay. So, good morning, guys. Good morning, Kishore, Pooja, Bhagirath, Raghunath, Priya, Yash. Okay. So, I think there are a few questions. Should we do it in the Jupyter notebook? You can do it anywhere. That's entirely your choice. No restrictions over there. Chalo. So I think in the last class we talked about how exactly this LSTM operates and what exactly are the architecture of it. So one of the very great use cases to LSTM is that it can work with the sequential data you provided, right? So today what I thought of that let's do something like that actually is working on the stock market predictions, like so not sorry the stock market prediction, the sequential data. So the best example for sequential data is the kind of data that is going around the market. So I have taken this one. This is stock market predictor, and we'll try to build it from the scratch. So I don't have any code as such. So we all will try to build a bit from the scratch. Okay. So we'll take some problems maybe. Can we do with you? Yeah, sure, dear. No need to worry about. You can do it. Okay. So let's take few questions over here. That's kind of like a problem statement at what we are actually trying to sort out. And then based upon the same, it will be easy for us to go ahead and it will be easy for us to sort it out. Right. So let's put some questions over here firstly, like what kind of questions what kind of business problem we are going to solve over here. So that's basically what I meant to say is. So let's see what are the business problems. So first of all, what we'll try to say is we'll try to observe the changes, okay, that we are having over the period of time. That is the first thing. Then we'll try to take the information about different things that are present in the stocks data. So firstly, we'll need to see the data in order to get this all information. So here I'm going to use a API that is pre-defined. Let me share it. So there's Y finance documentation. Not this one. Yeah, this one. So this is like a official page where all the Python packages are available, and you can see download market data from Yahoo Finance. So this is a real-time API that you can use, and you can get the real-time data from this one. So there are lots of companies that are available over here. You have Microsoft, you have Apple, you have Google. Every particular company is available over here. Okay, if you want to get an idea, so you can visit their GitHub for the discussion part and you will get it. Okay, sure. So we are going to use this one actually. We will use this and we'll try to grab data for some companies and we'll try to work upon it. Perfect. Sure, let's start then. I believe everyone is over here. Can I have a confirmation? Because I see still people are joining. So everybody is over here, right? Perfect. Sure. So how's the Josh, guys? Because I think this is the first time you guys are working with the real-time data, if I'm not wrong. Yeah, I'll share this collab link also. Yeah. So here's the collab link. Okay, and now let's begin. So with the very first thing that we need to do over here is we need to import our libraries. Yes, I think we should just observe and then after try it on your own. That's also fine. No issues with that. Actually, that will be good if you guys are observing side by side with me, and just for now, if you're observing, that's fine by me. There's no issue with that. Okay, chalo. So let's firstly prepare the room, guys. The room where we are going to work with the project. So I go with a step-by-step order. So the very first step that we are going to perform over here is the part of importing the libraries, importing the libraries. Okay. So I segregate the libraries on three bases. So first we'll have this configuration libraries. Okay. That will help us to configure our projects. So I'm going to use warnings. Firstly, in order to remove the warnings. Sir, I didn't get the link. Link for the collab, dear? You can let me know. Okay. Give me a moment. I'll share it to you. And why this Gemini is giving me this AI recommendation? I don't want that. Hide AI. Okay. So firstly, configuration libraries are those libraries, guys, in which we can like put everything like your warnings and all that. If you want to install some particular outer library, you can also use in that part. So that will be great actually. If you can go ahead and you can put like this again. There's no such thing as this particular thing is always mandatory. There's no such instance like that. But if in case if you want to do a quality code, this can help you out a lot. Okay. Now, from over here, what I'm going to do is we are going to use a library that is called date and time. How many of you have heard about date and time library? Anyone who has heard about date and time? From date, time, import, date, time. Why this is beneficial? So when we'll be extracting the data, we can mention that for how much period of time we need the data. So this library will be useful over there. Moreover, we need some classic machine learning libraries or maybe the always used one, that is your needed libraries for every particular work, right? So I think everyone is already aware about those libraries. I think NumPy, SNP, import pandas, SPD. Then also we need Plotly. How many of you have used Plotly? Anyone who has used Plotly till as of now? I've used? No? Okay, if you guys have not used, you are surely going to enjoy it out. Okay, this is an interesting, a rather much interesting library to explore. Okay, and again, this is something that is not in your curriculum, I guess, but if you guys want, surely please explore it. Okay, everybody. It shows value when we hover. Exactly, Lakshmi. Very good. Okay, it's like a best. Yeah, exactly. Very good. It's the best way to interact. Then on to the libraries that we are going to use. Can you please explain the warning to ignore part? So, dear, the thing is that whenever you are making some particular visualization, or maybe if there is some particular function that may get removed in the future, so it always pops you a warning. You might have noticed something like this. See, uh, future warning, right? And it would have written this function, something like this, right, Shriram? Check it out. If this thing might be there somewhere, see, images, it doesn't have any images as such. Let me open something, Python documentation. See, you might be having some particular errors like this: default, ignore, error, right? Depreciation warning. So these are the warnings that are there. Okay. So obviously, when you are working with the code, you don't want that this code should always produce a warning, right? You want that, no, I don't want warning. I want fresh code. So for that, we use this warnings filter. What does it? It ignores the warning. Okay, or you can see whatever it wants to do, you can do from over here. Chalo. Now coming to that part, I'm going to have some particular libraries over here as well. So we are going to use the metrics. I believe metrics is clear by everybody. I think no one is having doubts with the part of metrics, right? Your RMSC, MSc, any particular metrics, any particular evaluation metrics is inside this particular module, right? Then I'm going to say from Keras dot layers, right? I'm going to import two layers. That is, we need a LSTM layer and we need a dense layer for the output. Okay. And then I also need the sequential from the models. So we are making a sequential model. So we need a sequential part from over here. Sequential. Anything else that I'm missing? No, I don't think so. No, I think this will be it, guys. Um, I think if it will be necessary, we'll keep some library on go. No need to worry. Now, on to the second part, we are going to grab the data now. Okay, so this part is about grabbing the data from the API or by using this Wi-Fi lines. Okay, so have a check, guys, how exactly we use Wi-Fi lines. So actually, I have shared you the documentation already. You guys can have a look in the chat box. I think it might have been shared. If not, I'll just share it right away. So Wi-Fi lines is like a API that's provided by Yahoo. Okay, so using this particular library, you guys can get each and every information about each and every stock that you're having in the market or that is listed in the market at least. How exactly we are going to use it? It's quite easy. Firstly, we need to install it. Okay, I think I might be having the same in my system. But if in case you guys are not having it, just pip install Y-Finance. Okay, that's it. You need to just install the Y-Finance. Once it is done, you can import the same Y-Finance module not found Keras. Okay, it's free API. Yes, dear, it's free API, dear. Okay, requirements already satisfied. Yeah, I think it might be there in your systems as well, because if you guys are using Jupyter or maybe Colab, it would be there already. Okay, see, I also have that. So if you guys are using Jupyter or Colab, it might be there already with you all. Poonam, you are getting a error, model Keras not found. They just check it once if Keras is installed, or maybe you can just check if you are properly used Keras or not. Okay, chalo. I haven't installed. Okay, no issues. Then you can install it. Okay. But firstly, Poonam, please have a look onto over here. I'll tell you how to install it. No need to worry. I'll tell you exactly how to do it. But firstly, please have a note on this because this is an important part. Okay. I'm also mentioning the API over here itself, guys. So that if in case if you guys want to explore, you guys can explore it. Okay. Stock API. Perfect. Eh? What is the use of Plotly.express? It's a visualization library, dear. It helps you to visualize way better. Okay. It helps you visualize way better, and you'll have a look. Okay. Chalo. Now, guys, from on to over here, we will have to grab the data for a company. Okay. So if in case if you don't know, so for each company that is listed in the part of American stock market, they have a code. Like let's suppose for Apple, right? We have different code. Okay, see, for Apple we can have the code like Apple stock market code. I think it is actually the same. For Google, if I'm not wrong, Google stock market code, if I'm not wrong, stock market code. That is, I think, GOGL. See, GOOG. Check it out. Okay. And see, this is actually coming from Y-Finance, everybody. So if you open it out, you will have every particular list of, I say, Google. If you want to search for Amazon, right? Or maybe Nvidia, you can have a lot of things. See, Nvidia, NVDA. Okay. And then if you are searching on Microsoft, okay. See, MSFT. Okay. So the Y-Finance API actually works using this particular words. Okay. So if you want to grab a data, you need to use these words over there. So have a check how I'm doing it. NVIDIA makes graphics card. Yeah, NVIDIA makes graphics card, and they are one of the most leading ones right now in the neural networks technologies. Okay. So I'm going to say YF, and here we are going to use a function that is called ticker. Okay. Using this ticker, Survive Finance works with the Indian stock also. Bhagirath, I think they don't work with the Indian stocks. But in case if you want to explore it, let's check it out right now. Yahoo Finance. Okay. I'm not very sure. We can just search about Tata maybe. I see it is there. Tata NSC. Okay, so you can use this also. Okay. Now guys, using this ticker part, we guys can grab data. Okay. So the most oldest company that I remember right now is Apple or Google. So we guys can work with those particular data points. So for Apple, I think the code goes like AAPL, if I'm not sure. If that is correct, it will just give us the data directly. Okay. So we have got the data. See, we have got a green tick, so we will have the data. And even fourth, if you want to get the information about data, guys, just use this info function over here. Okay. df.info. What this will do, it will give you a whole history about the company. Check it out, guys. See, एड्रेस ओके यू लाइक हैव द होल हिस्ट्री लाइक पूरी कहानी आ जाएगी आपके पास देखो आप एड्रेस सिटी स्टेट कंट्री फोन नंबर वेबसाइट what kind of industry it is, what is the business summary, who is currently the CEO, right? So it is Timothy Cook, year of born, pay, okay, and all that. So everything, like particularly everything is mentioned over here about the company. Who is all the CEOs and what is the title of that there, what is the risk, what is the board risk, what is the open day, everything, guys. Okay. Akhil is saying, why do we use ticker? So ticker is the function that will call the API and will get the information for you. Okay, Miss Akhil. So this from over here, we have got like a whole information about the Apple's data, everybody. Now, how exactly am I going to use it? That's a question. Okay. So onto over here, we need data for a specific time interval. Okay. So let's suppose that I'm trying to grab the data for the recent last 1 year. Okay. What are API tools? Okay, you guys are not aware about API tools, guys? Everybody do let me know this, please. Are you guys aware about APIs and all that? We were told but not used. Okay. So see everyone, it's quite easy to understand. Okay. See, in the real world, whenever you're working, obviously the data, okay, it's not there in your computer, right? It is stored somewhere in the world. Okay. Somewhere in the world in some CPU. Now, obviously, no one can go to Brazil to get this data, right? So what we do is we generate an API for it. So API is like a link. It's like a URL, guys. Okay. Now using this URL, you can directly use this data into your project. Okay. And why finance is basically kind of like that. It basically what it does it gives you the access to the stock data present in the US market or in any particular market of the world that is listed. Okay. So using this particular module, we can grab any data that is present in the world related to stocks. Okay. And if you go through documentation, that is why I sure told you guys to just visit the documentation once. See, if you will see the documentation, right? So see, download stock market data. Okay. Wi-Finance, Yahoo are just Wi-Finance is not affiliated, endorsed, or managed by Google by Yahoo Insurance. It's an open source tool that uses Yahoo publicly available API. See, guys, we are using publicly available API as intended for the research and the educational purposes. That means this particular API is a public API and will be used for educational research purposes only. Okay. And then if you go ahead and you start with, so you guys can see the ticker module. Check it out. This ticker module will allow us to access ticker data in the more Pythonic way. Is it secure to use this project? Yeah. Sure, no issues. So how will you know which API to be used? You will have to research on it. Okay. For which particular part, which particular thing has to be taken. Okay. So let me grab something from over here itself. Let's grab this one. We are going to use a documentation a lot in here. So let's put it right. So we were grabbing data for Apple. So AAPL. How many type of API? Basically, that will be around the story. Okay, Sanju. We can talk about it in the another class. So for each and everything that you're using, there is a API for it. Okay, sure. So what I'm going to do over here, guys, please have a check. So I need to have the data for the last year. Okay, for the same day. So here basically I'm going to use this date and time module. What we are going to do is check it out. I'm going to create two variables. Okay, the first is my current date. Okay, what is my current date? So I can say date, okay, date time dot now. That means what is my current date and time. And similarly, what I can do is, let me remove this part for now. Okay, I can create a end rate. So what I will do is, we'll keep it like for the yesterday itself. Okay, so I'm going to say date time. I need it from current date minus one. That means today's date minus one. Then current month. Okay, that means current date dot month and current day. Okay, current day dot day. That means till today or before today, whatsoever data is present, we want that data. So this is for the current time. That means right now, and this is the end date. So if you might notice, it will also have year, right? So I think I have not mentioned year over here. I will mention dot year. So whatsoever year will be there, it will subtract minus one. So what is the year going on right now, guys? Everybody, 2024, right? So 1 year back, 2023. What will the month? The same month. What is the date? The same day. So we'll have 1 year data completely over here. How to grab it? Very simple. Data equals to Wi-Fi 9 will say, hey, download the data for which company? For Apple. Okay. What should be the start date? It will be our end date over here. That I want to start from this date. Okay, this will be a start date basically. Start date. Okay. So we'll say start date. From this date, we are going to start and go till this current date part. That means till today. We want data till today. Going ahead, see it has downloaded data for us. One of one completed. Now let's see the data. Okay, let's inspect the data, everybody. So if I say data.head over here, have a look, guys, everybody. The real time stock data, as you might notice, what's the day today, everybody? What is currently day today? Everyone, what's the date on your end? Everybody. 21, right? Correct. So see, what's the exact dated previous day? 21/6/2023, everyone. If we go with the tail, everybody, let's see what is the last updated record over here. So it's 20, right? What's the date 20 today? 21, right? So it's updated to the yesterday part. Perfectly clear, everybody? Anybody having any doubts so far? Can you explain the end data code? Okay, nah, sure, dear. Why not? It's very easy. See, you guys are getting, see. If I print current date, right? See, what's the current date right now? Check it out. It's 2024, right? Everyone have a look. Current date is 2024. What's the month? 6. What's the date? 21st. Correct? Hai? Now check it out in the start date here. Date and time. What's the current date I am given? Am I not writing 2024 -1? Right? Check it out. Just simply check it out. Current date dot month. So what is the current date dot month? 6. Am I not writing 6 over here? And current day, right? So am I not writing 21 over here? Check it out. Okay, it will not call directly over here. It will have date and time over here actually. See, got it? Everybody, have you guys got this point? How exactly this came and how exactly this came? Sakshi, are you cleared down now, dear? What exactly the dates and all this part? Sure. Now this is the data, guys, everyone. We need to work with this data basically. Now you guys tell me, firstly, let's try to analyze this data once. Let's see what exactly is the aspects going inside data. And guys, do notice one thing. So this open, high and low. Are you guys aware about this thing? Everybody? Anyone who is aware about this? Or is anyone who is not aware about it? Do let me know this, please. No, yes, okay. It's like polarizing. Okay. So let me talk about this once, okay? So guys, whenever I'm talking in the terms of stocks, so the first thing is that whenever we are having open, okay, open means at what the time the market is opening. Okay. Problem is that if we don't do parallel, then if letter initial, no one is there for help. I'm there, dear. No need to worry. Okay. I'm there. You guys can contact me out directly if you're having difficulty. Okay. Chalo, firstly, let me talk about. So this open in the stock market means at what price the market opened. Okay. What was the highest peak in the market? If you might have noticed, if I go ahead back to the Y finance part. Okay. See over here. If you might notice, guys, see, you can check it out. What is the highest? Okay. What is the lowest? So if there will be any high, right? So see the values will change. Check it out. Have a look. Close is at 178. High is 178. That means the top point. And the lowest was at 177. Okay. So see, that's what exactly high, low, and the close is. So close is basically at what price the market closed. Okay, at what price the market got closed. What was the last updated price for the market? Okay, is this clear to all? And volume is how much volume, or that means how much stocks were sold or how much stocks were traded in total. Okay, that means let's suppose a company is having 1000 stocks to be sold out or to be traded. So how much volume of the stocks are getting traded on daily basis? Okay. Can we have the respective name? I'll tell you how to grab the names. Don't need to worry about it. Okay. Chalo. Now, once we have got this data, guys, let's try to visualize this once and let's try to see what kind of data we are having over here. That's the first concern. Okay. So right now, I'm going to use Plotly, and you guys will see the difference between a normal plot and a Plotly plot. So for Plotly, the syntaxes are quite easy. We are going to create a line plot. Okay. We are going to use this data called as data, and from over here on the X part, I'm going to use the indexes, and on the Y part, I'm going to use this close. Okay. Title, we can mark it as the close price for Apple. Okay. Perfect. Correctly perfect. Chalo. Let's show him. Let me show it to you. Have a look, guys. This is what Plotly does. Everybody, have a check. Okay. And now, if you guys might be noticing, hey, Dave, seems like this graph seems something odd, right? Yeah, it's odd because if you can go ahead, you can check out everything. Have a look, guys. Everyone, you can literally hover and you can check. Okay, this is how the data is flowing over here. Have a look. If in case if you want to put something more over here, you can grab a list and you can say open. Okay, it will do that, I guess. It should do. Yes, see, open and close both at the same time. Okay, and you can actually visualize both of them. If you want to have this high and low also, just pull it over, just throw it out. High and low, correct? No, C1 doesn't works like this, right? C1 won't work over here. You can do it, there's no issue with that. C1 also works, Raghunath, but the thing is, if we have a better library with the same amount of syntaxing, I think this is better we can use it, right? Chalo. So let me remove this part and let's focus on the close part a bit because this is what we are going to work upon, everyone. So everyone, do let me know this. When you look at this graph, I think the trend that I can observe is in the mid. Okay, you can see over here in the mid portion when the market is near to July and this part, and same thing I can observe over here as well. Like you can might notice in the May part. Okay, May part. Okay, I can see a fall over here, like kind of like a fall stuff, because even from over here the data that is coming, I can observe that it might be having a fall, right? And here also we are having fall, correct? But I believe this data is sequential. Correct, guys? Everyone, we can make a sequential data from this or not? Please do let me know, everyone. Right? So let's firstly try to derive some inferences from over here. So I can check out that the stock market is there and everything. Let's confirm the same thing using the information function if we are having some ambiguity or not. So this is data information. Okay. So, sir, my graph has two colors, red and blue. Dear, you're using Plotly or you're using this one, Matplotlib or Seaborn? You can let me know. Okay. I copied your code. Okay, dear. So I have removed I'm only having one column as of now. You might just check. You might be having two columns now. Okay, the close and the open. You would be having both. So remove one of those and you will have the single color. Okay. Sure. And seems like over here nothing is wrong, guys. Everything seems perfect. There is no issue with the data type or something. So you might notice we are having 252 records in one particular year. So why we are having 252 records, guys? Everybody, can you please let me know why we are having 252 records? Anyone who can get an idea of this? Days, weekdays, yearly data. Guys, the stock market is closed, okay? The stock market opens only in weekdays. So in total, how many Sundays and Saturdays we are having? 52, 52, right? So 102 days gap, right? 102 days are weekends. So that is the case. That's why we are having 252 records. Everybody, 52 plus 52. And yeah, obviously. Chalo. So now let's try to analyze this data a bit, guys. Okay, we need to analyze this data a bit. so that we can get an idea of how exactly these all things are working. 104, okay, dear, I'll update it. Sorry, I think I'm bad with maths, right, guys? I think I'm too bad with the maths. Chalo. Now, once we have got this idea, let's try to grab some information on this part of closing price. Okay, let's try to see how exactly this closing price is going ahead. Okay, so the very first thing that we are going to analyze over here is the analysis, or the step number two, I would say. Step two, information on the close part. Okay, information on close prices. Okay, so here we guys can directly use the same code that we have used earlier. Here, this one. And let's try to analyze this part. Okay, let's try to analyze this part once. So guys, using this particular graph that you might see over here, please tell me what inference we can derive from over here. What are the things that I can say that, okay, this might be the curvature, this might be the trend over here. So I can see that if we observe this July wala period, okay, let me focus on this part. So if you focus on this July wala period, everybody, you might notice there's a fall that is going on. Okay, I believe everyone can see this, right? There's a fall that is going on. Okay, and if you guys are wondering that how I got to that part, so in Plotly you have the access. You can just select a time frame, and you can just check out that particular time frame, everybody. Okay, so see, from the last July, that was 27th, and this prime point 26 actually. After that, there's a hike, and then there was a low again. So this is stock data, so this ongoing ups and downs that are actually something that will be always there. But rest with the part, I can see there is a decline after this particular date, that is August 31, July 31. There's a decline completely, and further down the road there's also a decline, and there's like little bit up closure on this part. So going with this, I can easily say, guys, that means the data is having like a kind of what kind of trend we can say, kind of like up and down going trend, right? It is not very kind of like a straight data. The data keeps on fluctuating, okay, depending upon the seasons, maybe depending upon the economical status or the economical condition. Sideways trend, exactly, right? So tell me, guys, what are the insights that you can note out over here? If I want to write some insights over here that I want to grab from the data, what will be those insights, everybody? Noise in the data, very good. Noise in the data. But generally, I remember that there's no noise in this all data, because see, I won't say there's no noise, but we can reduce it. Okay, once we'll do the moving average to just get an idea about how much data is changing. So in that way, I think we can remove a lot of noise. Okay, because we'll only work on the changes then. So I think to eliminate this part, we can use the moving average, right? Moving average technique, correct, for resolving it out. Have a no exact trend, either positive or negative. Exactly, very good. We can also do that. Let me write it out. Have a no exact trend. This is shared by Bhagirath actually. So let me put it over here. Have a no exact trend, either positive or negative. And next thing, I think it's shared by Hemant. Upward, downward, and sideways trend. Stock is bouncing from the support. Exactly. Okay. So these are like the three insights that I think are very necessary, that we should understand. There's no trend as such. I can see there's a up down going on. So there's no positive, there's no negative part over here. Depending upon the market, the stock keeps on flying. Okay. Then obviously the trend that you can see, it's upward, downward, sideways, everywhere. Okay. So we have a different kind of data right now that you have seen. Buying this stock is risky, obviously. And guys, again, I strongly suggest you all to not use this particular thing in your real life to buy any particular kind of stocks. Okay, it is too risky. Okay, I'll suggest that no, don't need to go ahead and don't need to use this project to estimate that, okay, if I have to buy a particular thing or not. Okay, no need to do that. If you guys do that, then I am not liable for it. Okay, chalo. Now, once we have analyzed this part, okay, let's try to analyze the volume of the sales. Okay, let's try to analyze. The step number 4 is analysis or the information, information on the volume of assets traded. That means how much volume of assets a company is trading on a daily basis. Okay, so if you're not aware, I'll just put it in the very short note that it is basically the quantity or the number of assets that are traded between daily open and the close. So let me mention it out onto over here. This is what this thing is. Is the number or the quantity of assets or shares. Yeah, exactly, Lakshmi. Shares also comes on the same way. The number of assets or the shares sold between daily open and the close. That means once the market opens until the market closes, that is the number of, well, like how much number of shares are being traded on the daily basis. So that is what exactly is assets sold is. So on to over here, if you want to get an idea about the same, how I can do that, guys? Anyone? How we can do that? Again, we'll have to visualize it. Let's copy this code, paste it over here, and instead of this, I think I can use the volume, and we can say volume traded, volume trades for Apple. Let's see this. Okay, got a graph. And guys, you might see it is in millions. Okay, it's not in thousands or it's not in lakhs or something. It's in millions. Okay, so I can see. Can I say, guys, with respect of time, the volume of stocks that are being sold, it's basically increasing, right? You might have noticed it, correct? So there's a complete increase whenever we are talking in the terms of stock prices, correct? So that means the selling part, it's actually good. Okay, the stocks are getting sold. There's no issue with that. Okay, that means you guys can invest in. Okay, I think we guys can invest in this because I can see there has been a recent peak over here, right? This one that is around 163.224 million records sold. And then if I talk about this part, that is the recent one, that is in July 12, there was a peak in again the sales record. Okay, on July 12. Similarly, if you can notice over here, on July 12, if I go June 12, and here's July 12. So the closing price was 230. There's increase in share trading, but no relation with stock price. They are haphazard only. Kind of like that, we can say. Maybe on this date, there would have been some particular things in the international market due to which a lot of shares have been purchased. If you guys might have noticed here recently, let me quote the real life situation. Recently, when the election results were going on, I believe you might have noticed the people they purchased a lot of stocks because of being at the low prices, right? Because I believe some of you also might have invested your money over there. Okay. So the thing is that whenever there is some certain kind of scenarios in which the market seems to be odd, people tend to buy a lot of things, right? So this might be this these days could be might of that particular scenario that in these particular days there would have been some scenarios in which the purchase of the stocks would have been a lot higher than what we see. So that is what I can consider from over here. Now let's try to work with the part of smoothing it out because obviously we can see that there's a lot of fluctuation that is going on. And obviously I can't work directly on this data. So I need to work with it. I need to smooth this out data. Okay. I need to like make this data to work with. So let's try moving averaged. And I believe everyone is already aware about this old technique that is moving average technique, right? I believe this is the most oldest technique that we have been using, right? So what this will help us, it will help us to find out the updates that we are doing on the specified time frames. Okay. So let's suppose what is the change in the last 10 days and we'll keep on rotating that window. So let's try to firstly find the MA data. Okay. Finding the MA is the moving average over here for the data. Let's try to find it out. So I'll say moving average equals to, and let's try to calculate moving average for 3 or 4 intervals. So we'll say 10 days, we'll say 15 days, we'll say 20 days, and we'll say uh, 30 days. Okay. This is the moving average that we are taking with their sequences. So it will calculate the moving average firstly for 10 days, 10 days, 10 days, 10 days, 10 days, so like that. So it will have 25 things. Then it will take for 15 days, it will take for 20 days, and then for 30 days. So I can say for X in moving average, I want to create a column, okay, that, sorry, that would be said as FMA for X days. That means whatsoever number of days we are having, we'll have a column for that. And in my data, using this column name, I'm going to have data close dot rolling. Window size will take as the same thing, this x1. So x dot mean. I believe this code you guys have already seen, right? Data dot whatsoever you're having dot rolling dot mean, right? So this is what I have created right now. So we'll have four different columns that will be marked as MA for 10 days, MA for 15 days, 20, 30 days. Okay. Let me run the code. Let me show you the last output. So if I say in data.head now, okay, so you might see nan over here because obviously we are rolling the window. It will give us for the next 10 days. So we will have 10 nan values over here, 10, 15 nan values over here, 20 nan values over here, and 30 nan values over here. So again, we can drop this off with and we can get the proper result. But in the visualization, it won't be there. We'll have after 10 days, 15, 20, and 30 days. So let's try to talk about a tail over here. I think in a tail we'll have much more information. See, average for 15, 30, and all the days. Okay. So let's try to see which one actually works for us. Okay. Let's try to visualize the results. Okay. Visualize the same for getting an idea which is perfect. Okay. So for visualizing, guys, can we use the plotly again over here? Let's try to copy this up. Okay. Let's try to put this over here. And we need these four things, right? So let me copy it from over here straight. Let me put it down over here. Okay, perfect. Yeah, it's perfect. Just we have made a bit of mistake. Not a mistake, I would say. It's just like we are trying to implement it. Okay, great. This is also something that we need to work on. Quotations. And then I can put it like this. Okay, perfect. And it's perfect. Should we run it, guys? Everybody, everything seems fine till this point of time. Anybody having any issues? I believe everything seems okay. What is the shortcut to for the both the brackets you have placed, sir? Bhagirath, in Colab actually it automatically gets it. I don't need to use anything as such. Okay. In Jupyter, I think you will have to put the both the braces. Okay. Now have a look, guys. I think we have not printed the original data. So let me print the original data as well. Close. Okay. So guys, see this blue line over here. This is the close one. If you might observe the other colors. Okay, let me zoom it a bit. Okay, let me focus on this time interval. You might notice the other particular parts, they're starting from the date that we have mentioned. So if you might notice, the first day in the data is June 23, or maybe it should be June 21. We can't see that part. If I'll zoom it a bit more, we'll be able to see that. So after that, the first MA is starting from 5, MA for 10 days. Then it is for MA for 15 days. And this is the MA for 20 days. And for 30 days, we are starting from over here, everybody. Check it out. Okay. So I believe now everyone is clear about how exactly the NaN values were handled, right? So in the 10th part, we were having only 10 NaN values. So it was till this point. In 15, we were having till that part, right? And then in 20, we were having, so you can also observe the gaps. They're like equivalent gaps, right? See, 5th of July. But why we need this? Let me tell you. Thing is dear that there's a lot of things that are going inside the graph. So we need something that can explain us the proper curvature, maybe the trend, maybe the changes that is going inside the graph, Shivani. Right? Because obviously you can't observe the changes just by looking at this because that's the individual data point, right? We need something that can tell us, okay, this is on an approximate, on an average, this is how much the graph is changing, right, Shivani? So that is why we need this moving average part. Okay. One more thing, guys. If you notice it out over here, the MA for 30 days that is in the yellow color, it is too smooth. Okay, it is too smooth. If you notice the yellow line, it's basically flowing in a sinusoidal manner. See, yellow line, it's basically very smooth, right? So that means this yellow line won't be useful for us. Why? Because it is too smooth. It won't be able to tell us the exact ongoing parts. Okay, that means how much change in our data is going on. Because if you notice, it is just flowing around over here and there. So this is not good for us. Now, if you check around the 20, 15, and 10 days, so I believe the 10 and the 15 days looks more promising to me. 10 days obviously gives us a more big idea. See, it is smooth throughout the time period and it is capturing each and every essence of the data. Can you notice it out, guys? The red one, right? And then if I talk about the green one also, so let's remove these two, 20 days and 30 days. Let's focus on those that are workful for us. So if I notice in these 2 points, see, the red one seems to capture a lot information and the green one also captures a lot of information with respect to the what we have seen earlier. Don't you think, guys? Everybody. That at MA for 20 and 30 days, they were not able to capture this much information. They were not able to explain us the trend and all that part. But I believe this red one is able to explain a lot of things that how exactly data is changing. Correct, everybody? Does everyone agrees with me on the same or not? Please do let me know, everybody. So that means if I want to get an idea from over here, what I can say, everybody, what will be the insights from over here? Everybody, do let me know this, please. Take an idea. Can I say, guys, based upon the graph, the MA that we have taken for 30 days, right? Or maybe like 20 to 30 days, that was not able to give us the complete information about the data, right? Correct? So I have written a note over here. You guys may have a look onto it. Okay. So according to me, I think the data for that rolling mean that we have taken out 15 or 30 days, 15 20, 10 or 15 days, I think that seems more promising. And I have mentioned the same thing. The MA taken for 20 to 30 days is not able to give us the complete information about the trends. It is too smooth with the respect of data. If you look on the MA of 10 to 15 days, it seems more promising as it captures more information into it. So according to me, we can move forward the MA data having average rule between 10 to 15 days. My personal recommendation is 10 days because it seems more promising, everyone. So I have written my recommendation over here. Again, that's entirely upon you which one you want to go with. So I won't stop you, but this is my recommendation. Okay, that 10, because to me, 10 days seems more promising over here because it is able to capture all the way, like all the information, the trend and all that. Perfect, everyone, right? Now, here comes the important, guys. Okay, here comes the most important part. Whenever we are dealing with any kind of stock, I think everyone nowadays worries about how much return they are getting. Okay, so what is the daily return on the stocks? I believe this is the question that everyone is having nowadays. That how much is the return, right? I think I have misplaced some of the things, so this will be 3 over here. That will be 4. That will be 5, and this is going to be 6 step. Okay, chalo. So now, guys, tell me how exactly we can calculate that. How much return a stock can give us, everyone? Just think of it once. How exactly, if I give you this scenario that okay, you have to go ahead, you have to calculate the particular return that that a stock might give us to us. Selling price, buying price, okay. Opening scroll. That means, guys, what is the? Can I say that basically, if we go ahead with the difference, can I say that how much is the percentage change between open and the close price, or in a sense, can I say that how much, okay, could be the difference between a closed data, the percentage change in the closed data, right? By how much percent each and every data is changing, right? So that means we need to calculate how much the stocks are changing on the daily basis. That's the first thing. That is the very first thing that we have to do. So let me mention it out over here. We need to calculate the change in the prices on daily basis. Okay, that means earlier what we were doing, guys, we were observing the changes, but on the average basis, right? Isn't this the way we are trying to observe the changes on the average basis by taking the average of 10 days, then moving forward, then again taking the average of 10 days, correct? Now, what is the thing over here? Aren't we trying to go ahead and aren't we trying to work with the part of individual data? Correct or not, everybody? Right? Okay. So over here, we can use a function, guys, that is called as, let me firstly mention, uh, returns that we are talking about, right? So let's keep it a name that is daily change, or maybe um, daily percent. Okay, that will be good. I can say data close, and I want to get the percentage by which this data is changing on daily basis. So I can say PCT. I am not sure what is the function name is. It's PCT change, I guess. Let me just see the documentation. I think it's PCT change or maybe something like this. Let's try to run it, and if it will give error, we'll check the documentation. So this PCT change is kind of a function that basically, I think by a name only it's clear, it's percentage change. That by how much percent on daily basis this close is changing. So if I run this code, okay, it went ahead. That means the function is correct. Percentage change. Now let's try to see by how much percent on daily basis. Try to visualize to get an idea of how much change it is happening now, how much change we are having on daily basis. But before doing that, let me give you a rough idea. So guys, if you notice it out, the close column, how much is the percentage change over here? I think very, very small percent change is happening, right? From here to here, I guess if you get a division, so what is the division difference? What is the percentage difference between 212 and 214? If you divide 212 by 214, I think the percentage change that we are going to have, it will be like minimal, very minimal actually. If I'm not wrong. It's like 0.009% change. What do you say, everybody? Correct? Eh? Very minimal changes, right? So let's try to observe those minimal changes only, okay? Let's try to analyze each and everything that we can see. Every information that is there in the data, guys, is important, okay? It's not like any information is not relevant to us. Everything that we can derive from data, that's important for us. So daily percent, and this is the percent change on daily basis for Apple. Oh, got it. So as seen over here, guys, you might notice that on daily basis, the fluctuations are there and they are nearly between 0.2 to minus 0.2. That means 0.2% change means it has been increase in the prices, and minus 0.2 means obviously there is a decrease in the prices. So overall, I think this thing makes a lot of sense, guys. Can you see? Everybody? Now I think everyone can correlate why here there was a lot of sales. Everybody? See the difference. On 12th June, there was a lot of volumes that were sold. Okay. On 11th June, guys, see the percentage of change in the close, right? So that means on 11th June, the percentage change was 7%. There was 7% increase in the price of the stocks, right? So that's, I think that's a very clear now that why exactly the lot of volumes were sold. Correct or not, everybody? Do let me know this, please, everyone. Similar thing I see over here also, right? On the May 3, the percentage change was 5%. And if we go back over here, on May 3, the volume sold was 163, right? Correct. So these are like the small bits and pieces of the information that you guys can grab from the data, okay? And this will actually help you understand how exactly the stock is flowing out. Okay, everybody. Even if you want to get an idea, you can also use histogram over here, okay? That use histogram, okay? For getting an idea about what is the average change happening, okay? Let's try to use that as well, everyone, so that you guys can get a clear picture of how what exactly I'm trying to tell. So for this, we'll have to change the syntax a bit to histogram. That's it. And I'll have to say data. In the X part, I want to have my daily returns. Okay. And the title would be is daily returns or is daily what? Daily percent actually. Let me copy this. Let me paste it over here. And title will keep as change in stock. Simple. Okay. Fig.show. Let's wait. 3, 2, 1. I think it should print it now. Yep. So have a check, guys. As seen earlier, I think you might have observed in the graph almost that on an average, there is a fluctuation is between 0.2 to 0 minus 0.2, right? Everybody? Isn't the same thing happening over here also? The majority of fluctuation or the majority or the frequency of fluctuation that is most in this is in this zone only. Perfect, right? So that means, guys, if let's suppose I'm just telling in a real life scenario, again, as said, disclaimer is none of the things represented over here will be working as the same in the real life. Okay. So if you're investing, invest on your own risks, everyone. Okay. So if I talk in this particular condition, I can say that if there's a particular change, so on an average, if we take an idea, in the majority of the times the change is between 0.2 to minus 0.2 to minus 0.2. That means if we observe the change on an average, there's like 2% change in the stocks. Correct, everyone? Is my understanding correct till this point of time? That means if we are investing in a stock, we can expect that our stocks might fluctuate 2% on the both ends, on the negative and the positive ends, right? So what do you think? What could be the real-time inference to it, everybody? What I can say as a real-time inference, if my stocks is fluctuating by 2% on daily basis, what I can say, everyone? Think of it. What exactly could be seen over here, everybody? Risk is minimal, exactly. Safe to invest, right? Because 2% change is very uh, minimal change, right? We can expect that to happen, correct? That means it is safe to invest in this stock, right? Everyone, right? It's safe. Do I have a green tick from everybody? We can invest. Sure, then I'll just invest today in this. Okay, fine. Now we need to also analyze one thing. How much is the risk, right? I'm not very sure how we are going to analyze that. Anyone who can give me the idea, like how exactly we can analyze the risk? Everyone over here, tell me how we can analyze the risk over here. I'm trying to think of that. Let's try to do one thing. Let's try to calculate the mean over here. Okay, let's try to calculate the mean for adjust. Yeah, exactly. So fluctuations, for the fluctuation, what we are going to do, guys? We have a column over here that says adjusted close. Okay, that means what is the optimal close value. So we can use this value and we can take out the mean over here. So what we'll do, what I'm planning to do is see. Everyone, let me make you understand my procedures, like how exactly I'm thinking of. So my understanding is that analyze if the risk is short-term covering happening on the based on volume fluctuation. Exactly, that's what I'm also thinking. So what I'm thinking of is there that if in some of the other way, if I can calculate the mean, okay, mean percentage, average percent change with respect to how much our mean is, how much our data points is fluctuating from the mean, right? So then I think we can get an idea of how much risk we are having, right? Using a scatter plot, I think we can get an idea that if I get an idea at how much from our mean each and every data point is deviating, that means by the mean, that means by the average pricing, by the average close, how much our data points is fluctuating. If there's a lot of fluctuation, that obviously our risk is higher, right? And if there's minimal fluctuation, that means our risk is low, right? Because see, if this is your average price of a stock, and if your data points are very close to your mean, right? That means, guys, there's minimal fluctuation, right? It is safe to invest. Can I say like that? General assumption. I'm not talking about anything as technical, right? It's very general. Like if there is something as median, right? If it is your average over here, everybody, this is your average. Let's suppose if I take an example of class itself, if you're in a classroom, right, and the average marks is 70, and if you're fluctuating near around 70, like 68, 69, 67, so then that's perfect. That's not a issue, or is that a issue? Please do let me know. Commenting that part that we have 2% of change on daily basis. Everybody, keeping that in mind, do let me know this, everyone. Is this a lot of risk? Is this a lot of danger if you are around 68, 69? No, right? It's fine. Correct? But if the fluctuation is lot, like you have average of 70 and you have got a scored around like 98 or something, that means there are a lot of fluctuations. Correct? Okay, so if that is the case, I think what we can do is, can we calculate the mean and the standard deviation, everybody? Because standard deviation will help us know that what is the fluctuation from the mean is, and mean can help us understand the whole procedures, right? Easy. So let's try to do that. I'm going to make a separate data frame, by the way, for this, so that we won't hamper our original data. Okay, I don't want to hamper that. So let's work with the risk part. uh, Over here it's daily returns and all that, so let's put it over here. Step 7 it is, if I'm not wrong. Yeah, it is step 7, and again I missed out this part. Perfect. And now onto this part, we are going to have a step number 7, analyzing the risk. Okay, so let's try to analyze the risk over here. I'll create a risk data in which I'm going to use data from adjusted close. Okay, that's the approximate close, and then I'm trying to grab the percentage change from over here. That means what is the percent change happening. Along with that, I'm also drop the data that is not of our use. That means the null values. Okay, let's try to use that risk data over here. I made a mistake. Perfect. So we have got the percentage change over here for the days. Let's put it into data frame format, everyone, so that we can use that. So period or data frame. सही है. Now I think, yeah, it's perfect. Date and they just close. Perfect. Okay, now let's try to plot this out. Okay, let's try to plot this out. And how should we go ahead with this? Let me think of it. So we need to go ahead. And let's first let me try to analyze the same in the plotly. Sorry, not plotly, in the matplotlib, so that we can get an idea of it. So plt.figure, the fig size equals to 10.8, and let's try to use a scatter plot over here. We want, from the risk data, I want to take the mean, and from the risk data I want to take the standard deviation. Okay, and I want to plot this both actually. So X label, we are going to have estimated return percent, and in the Y label we are going to have a risk percent, and then let's try to show it. Let's see how it works. I'm not very sure that if it is going correct or not. It's just like we're experimenting right now. Okay, we have got an idea. See guys, everyone, it's 0.138 is 0.00063. That means as seen earlier, everyone, I think we have already concluded that the risk, the fluctuation is between -2 and 2 on the average. So it is saying that if you're willing to take 1% of risk, the expected amount of return is 0.000063. That means 3 times 0 and 63. Quite a less return for 2%. What you can say, 2% risk, right? Correct, everybody. I believe that's the same case over here. Right or not? Do let me know, guys, because you can see this is the percentage risk that we'll be taking, and this is a return that we can expect. Everybody, mm, not too good actually. So I think this is a stock. If we take a risk, it is not beneficial for investing, right? Estimated return is too low. Chalo, fine, perfect. Okay, and do let me know, guys, if you guys have understood this thing, how exactly I have calculated. Everyone have understood ROI is low. Yeah, return of investment is quite low. Exactly. Perfect. Till this point, anyone having any doubts? Because after this, I'm going to train our model over here. We'll train our neural net over here on the LSTM part. So is everybody clear till this point of time how exactly we analyze the stock data? And it's just a basic, guys. Okay, that what I'm telling. There's a lot of things that you can analyze a bit more over here. So I'll leave that to you to analyze how much you want to do. Please repeat which part, dear. Poonam, which part you want me to repeat? This one? Analysis. Okay, for the analysis part, dear, I'm telling that. See, a lot of things we can do over here. Like I have just analyzed the basic proportion of it. Okay, like the basic things, like how exactly you can get the information idea, how much that the stocks are being traded, how these two things are related with each other. Right. So I was just trying to tell you that there are a lot of things that you guys can do on your own actually over here. Okay. So if everyone is fine till this point of time, can we move ahead to the model training part, guys? How did you get the risk data? Very simple, dear. See, let me go above. See, data adjust close. That's it. We just grab the data from adjust close. That's it. And we have taken the percentage change. That means how much percent it is changing with Aramba. Sure. Can I have a confirmation from everyone over here? What's the status? What is adjusted close? Basically, dear, if you go in the data, let me talk in. So here we are having data, right? See, you might notice at the end of the day, it is basically the same thing, but in a more like, let's suppose that there's a lot of fluctuation. So on average, you can aggregate it. Poonam. Okay, like what exactly is the kind of, you can say, what we say, I'm forgetting that word, guys. Can you please suggest me a word for adjusting part? I'm just forgetting that word. What was that called as? I forgot that. Wait a second. Yeah, see, it's basically like it will adjust the close price to today's previous and average it out. Exactly like that. So basically, dear, it is like kind of like you can say a more accurate indicator of the stock values. Okay. So since your closing price has already been done, see, this is your closing price at what the market closed off, and this is the opening price. So in between there was a lot of fluctuation. So this will give you an overview, like a current, like the whole idea about how much, like what exactly is the close price of today. Exactly, correction. Exactly. Thank you, Mr. Shashank. Very thank you. It's like the corrected close price, you can say, the aggregated close price onto overall. Chalo. Everyone clear till this part? Anybody having any doubts with this one? Anybody who is not able to understand? I believe till this part was quite easy to go ahead with, right? Whew. Chalo. Do you guys want a break or should we continue, everybody? Do can let me know, everyone. You guys want a break? So let's take a quick break of 5 minutes over here. And after the break, we'll start working with the model. So we'll start segregating the data and we'll start working on it. Okay. So it's like 8:10 right now. Please be back by 8:15, everybody. Exactly, Shang. So basically, I think, Mr. Shang, the main objective behind doing so is that mainly other like there are two, three objective mainly whenever we are going with the stock prices. So one of the main objective, I guess, is to find how much fluctuation is there. So because see, whenever I'm investing, I always want to know that how much the stock can fluctuate, or maybe what is the kind of um, risk that I should be willing to take. Like that's why I told you over here that these all things are like some of the basic things that everyone analyzes. So this will help you to analyze that how much risk we are taking, and then what could be the maximum returns. So all over here, I can expect that okay on the percentage return is this, so accordingly I can calculate. Other than that, there are also other objectives like they also want to know that okay, how at what price the market will start today, or maybe what will be the price, or maybe what will be the perfect timing. Because if you might notice, there are some perfect timings at which the market is at the highest peaks, right? So also some people try to analyze that what is the best time to invest, like what is the best time according to the hours to invest, right? So those are also the techniques that are used actually. But furthermore, I think mostly you'll be using again as you said the price for the stock, the close price, and the maximum returns, and the risk also. That is also one of the factors. Okay, Bhagirath is saying today's hands-on session is very nice experience. I appreciated you didn't just present pre-written code, instead you guided us through the process, allowing us to understand each step and practical applications. Oh, thank you. No issues, dear. I think that's how exactly it should be, right? Uh, I believe so because whenever there's something that is hands-on, I think that is something that you need to. Everyone needs to understand that this is something that is needed to be explained and their real life implication also. Because then hands-on doesn't make a sense if it is just putting up the codes and just writing it out. Okay, according to me, I'm not clear about the other people opinion, but according to me, if there's a hands-on, so you need to write the codes. Okay. And to be very honest, I think the best way is to go with a blind analysis. Whenever I go to any hands-on, I don't have any pre-prepared code. Okay. Okay. Anything as prepared, I don't use that. Okay. This is the first time happening in the interlibas. Okay, might be my style of yeah, making someone study would be different. Okay, but whenever the other mentors come, they used to have pre-turn codes. Okay, there the thing is that maybe there would be have been a time constraints, right? So that's why they might come with pre-return codes, right? Because see, always there's a lot of theories, there's a lot of practicals that are going on, right? So might be there would be time constraints. Nevertheless, fine. Just enjoy for today. We'll see what happens for the next time. Okay. Whatever has gone is gone, guys. Okay, so we can't focus on that. What is right now is it's what in our hands. So let's enjoy that to first. Chalo. Okay, I believe everyone is back over here again. Anyone who is missing out, because now we are working with the training and the testing data. Okay, so earlier we had like a very small data, right? So I'm now going to have a kind of a big data. Okay, again we are working with the data that will work for a less last 10 years, let's suppose. Because if you might remember, guys, in the theoretical class, I told you that if we are having a very small sequence, right? So we can use directly the RN. What is the use of LSTM, right? LSTM could be used when we are having a large data, okay? Data that can easily make the RN forget about the context, right? So let's try to grab a bigger data than the previous one actually. So data equals to YF dot download, okay? Okay, Sakshi is saying, I agree with you guys. Okay, dear, I didn't got you. You're agreeing with me or you are agreeing with your colleagues? Chalo, no issues. You guys can continue. And over here, the start date, everybody. I'm taking the start date directly back 10 years. Okay. 10 years back, so what was the year, everybody? Right now it's 2024, right? 10 years back is 2014. Let's take from 2014. Okay. And the end date will keep as the current date. Let's download. Data downloaded. Everybody have a look. We've got data for the last 10 years. And let's try to plot this out. We need the code for plotting. So let's go ahead. Let's copy this. And let's go back over here. Let's see how much fluctuation we have done in the last 10 years, everyone, on the given data. Oof. Have a look, guys, over here. That means I can easily say there's an increasing trend, right? Everybody check it out. Now, is this thing more clear? If you're talking about the last 1 year data, I believe we were able to see not a like a kind of up and downs, a lot of up and downs, right? But if you see in the long term, guys, are we seeing an upward trend, everybody? A clear upward trend, I guess, right? That's a clear sign that okay, the data that we are having is having upward trend, and more of it also have seasonality because in between there's fluctuations. Perfect. Chalo. Now, what we am going to do is I'm going to separate our data, okay, because we are going to work on a single column, okay. So I'm going to separate this particular data. Let me mention it out also onto over here. We'll be creating a separate data frame that will only have the close column so that we can focus only on that. So I'll say df close, okay, data. I want this close column and df close. Let me have a check. Yeah, see, this is a df close. And you might notice the change in the prices, guys. See, in the earlier 2014, the price of a share or where the closing price as 24,102 was $19. And check out the price in 2024. How much percentage? I think it's like 100, not even 100. Yeah, it's like 20 times increase in the prices, if I'm not wrong, right? Post COVID, it has changed. Yep, I think till this point of time, it was very, very, very natural. Yeah, post COVID, there was a tremendous increase in the prices. We should have invested. Sure, no issues. Now let's take the length of the data so that I can get an idea at how much we have to go ahead and how much I have to train and how much I have to test. So I'm going to take the length. So we are having 2634 records. So let's grab the number of rows. So what I'm thinking, I'll take 90% of data in the training and 10% will keep for testing. Okay, grabbing the number of rows for testing and training. For training firstly, I need for training firstly. So let's go ahead with that. So train length is going to be how much? Uh, Length of the close, and we're multiplying it by 0.90. That means I want to take the 90% over here. Okay. And yeah, obviously, if it is going to give us the particular float values, I can use the seal value over here. And I want the integer. So I'll just typecast into an integer. Okay. And if you guys are getting confused, what you have written, so let me explain you. Let me break down the code for you. This is what I have written, 90%. So it is giving me a float value. What I'm doing is I'm just converting this whole thing into a seal position. Seal means the top position. See, Sanju, have a look. Okay. So this is the current value right now. If I go with seal value here, that means that what is the value written over here in the point? It's 0.6, right? What is the closest value to 0.6? 7. If we approximate, it will be 7. Right. So if I write np.seal over here, the seal means 2371. Check it out. Okay. If I write floor over here, it will be 270. Okay. See, it will be 270 over here. So I'm taking the seal value over here. And moreover, since I want the length, so I am basically taking it as an integer. See, 271. So this is going to be the length of my training data. And that is in my train length. Everybody. Perfect. Chalo. Now let's try to work with the data, everybody. Okay, let's try to work with this. Okay. So this was step 8, right? Now let's just move to the step 9. Show whole data would be considered training. No, dear. This just this much part. Okay, this much part. The training length. Other data will keep for testing. Okay. Can you repeat on training length? Sure, dear. Why not? See, very simple. Length of data frame, right? See, df close dot length. First, let's break it down. Okay, very simple thing is let's just break it down. Okay, just keep following me on this. Length is this much, right? I am willing to put the 90% of the data into training part. So multiplied by 0.90, length multiplied by 0.90, 90%. Going ahead, I got 2370.6. Now obviously I can't use the point that I can't be that much precise with the length, right? We need actual length, absolute values. So can we do a seal over here, right? 2371, that's my training length. And obviously I wanted it in integer, so I have just converted it whole into the integer part. See, 2371 now in the integer format. Generally wait, if we take 8020, you can take that also, Raghunath. There's no issue with that. Okay, there's no issue with that. You can go ahead and take that. Okay, I'm just taking generally. Okay, just an assumption. You guys can change it later on. Okay, df close will take the entire set, only the close value, Poonam. Okay, only the close value of the data. Okay, only the close value. You guys are not aware of CL. Okay, let me tell you, everyone. See, 11 divided by 3. How you divide it? 3 times 9, 2. Okay, have a look, guys. Put a point. It will be 0. 6 times 18, right? Again, it will be 6666, correct? So now if I take the seal value, seal means the value that is just, see, this value is ranging in between 3 and 4. This is your floor value, this is your seal value. Okay, floor means this one, seal means whatsoever is greater than this. Okay, if it is 3.12, the seal value for this is going to be 4. Top round value, exactly. The next greatest largest. Perfect, everyone. Is this in clear, everybody? The seal and the floor part? Sure. Now, this is actually one of the crucial steps, guys, that I'm going to do right now. Okay, I'm going to work with the prediction of data. Okay, working with the prediction of the data, right? Now, guys, over here, I'm firstly going to scale the data. So anyone, can you please tell me why we are scaling the data? Anyone who can tell me this, that's why we are scaling the data? My question, not you know, have patience, dear. I'll answer it out. Okay? No need to worry. You can just put it again. I think it might have been missed somewhere. I'll answer it. I might not have seen your question. The question from my end is, guys, why are we scaling the data? Why we are scaling the values over here? Close value moving outliers. No. Close values. We are only considering the close column, Poonam. We are only considering the close columns. Okay. To check the trend in the long term, easy to calculate time saving. The first thing is good. Ankur, I think that was not correct. Not to check time trend here. I'm calculating. I'm converting. I'm scaling the value so that it will be easy for us to calculate. And guys, let me go back in the last class when we were talking about the vanishing gradient and the exploding gradient, right? So the first thing is that if we don't scale the values, let's suppose, so there might be some values that are very small. There might be some values that are very big, right? If you notice it out of data that we are having, it's the first thing that you might have noticed. The first data was 19 and the last data is 212, correct? Poonam, I'll give you the access. You can ask me at that time, okay? I think that will more easily clarify you out. So at this time, dear, if you notice, there's a very, very huge difference between these 2 points. So what will happen is if you don't scale the values, the model will get biased towards the dominating values, this one. Okay, and it will be a very big problem for us. So we can scale these values so that each and every value will be on the same page. Secondly, if there is no big value, there'll be no problem for the vanishing gradient or maybe the exploding gradient. Okay, we won't be having a problem of vanishing gradient over here. Okay, because what will happen, that model will start from the smaller values, but eventually it will encounter the big values. So at that time, the scales will be very less, the gradients will be small. That will encounter the vanishing gradient problem. If everything is on the same page, we won't have that problem, right? So very first thing is we want to remove the dominant values. Okay, and that is the main thing. That is why we go ahead and we scale the data, everybody. Okay, shall I? We do scaling to optimize the performance also. That's also one of the things. Yes, correct. Exactly. Right. So onto over here, we are going to perform this using min-max scaler. So what is the features of min-max scaler, guys? Can anybody tell me? What is the feature of min-max scaler? Tell me, everyone. I think it's quite easy, min-max scaler part. It's one of the easiest scaling technique I think I have heard of. Tell me, guys. Oh, this should not be there. See, very easy. Okay, min-max scaler is a technique that scales your data between 0 to 1. That's it. Okay, exactly. It's normalization. Very nice. Simple as that, guys. No need to worry about it. It's very simple. Just a one-line definition test. So let's transform the values of TF close. Okay, transforming. And one more question, it is saying expected 2D got 1D instead. Okay, so it was expecting 2D from us and we have given 1D to him. Okay, so let's fix it up. Over here, we can fix it out directly. Let's put it inside these two braces. Perfect. Let's run it down. Perfect. Got it. Using a fixed range of value, easy for calculation. Yes, I can exactly. Now we have scaled the values. Now here's my question, guys. If you're scaling, okay, what we get in return, everybody? Can you please tell me what do we get in return, everyone? If I'm going to print a scale, no, that's fine. That's I know. Okay, that I know, dear. I will get between 0 to 1. But what will be return type of this particular function? Can you please tell me, everyone, that? Why do we need scaling? Indrani, I think you might have missed the discussion over here that we were having, but let me recap it for you. So, scaling is used whenever, firstly, to remove the dominant values. Secondly, it eases up the calculation because we might have bigger values, smaller values, and it will make the model more complex. So, it's better if we can scale down the values onto the same scale, onto the same page, so that the model's evaluation could be easier. Okay. Okay, float, integer, tuple. Guys, how you guys can forget? See, it returns as an array, everybody. The array of scaled values. Have a look. If I put it in a data frame, okay, and if I mention over here column equals to scaled data, okay, check it out, everyone. Have a look. Isn't this the scale data that we are having? Everybody, correct? Hai? Anybody having any doubts? So if we take 1 year data and we do scaling as they are most similar. If you're having only one year data there, I think there's no need to do the scaling because almost each and every data point will be on the same page. Okay, there will be very less fluctuations. You can no need to do scaling. You can directly proceed. Okay, sure. So we have got the scale data, guys, and now let's split the data, everybody. Okay. Now here is actually a bit complex part, everyone. I won't say it's complex, but it's like a mere understanding. That's a general understanding. We are working with the step number 10 actually over here. So let me mention it out. Step number 10, splitting the training and the testing data. Okay. So firstly, we need to create a train data. So let me mention it off. We need to create the training data. Okay. So for train data, guys, have a look at what I'm doing. I'm saying from this data is scaled. From this scaled data, I want to grab from zero length to a train length. Is my understanding correct, everybody? Let me know this, please. Is my understanding correct, everyone? Right? We need this data, and it's in a 2D format, so I need to mention over this one also, the comma. Okay, that means consider all the columns, that whatsoever column we are having, though we are not having any columns, but we have to mention because it's 2D. Okay, this is our train data, everybody. Okay, now guys, if you remember, we need X train and Y train over here, right? So we need to split the training data into X and Y. Now here is a crucial part, everybody. I want you all to firstly understand, guys, whenever we are talking in the terms of RNN or something, that means we are going to have a sequence of inputs, right? I think that's what we discussed. So that means for learning or for predicting any particular data point, let's suppose for today itself, we need to give an idea about the previous few data points. Is my understanding correct for this one? Right? That means for predicting one value, we need to have a batch of 60 values, right? We need to create a sequence of 60 values each, right? Okay, let's suppose if I'm considering 60 days over here for predicting one data point. Okay, or maybe you can consider any number of days. So for predicting one particular day, we need to look onto 60 particular values, right? That is how exactly LSTM, or that is how exactly RN or something works. Is my understanding correct? So that means over here we need to use a loop approach to make that data. Okay, we need to make the data by our end. So let's have a look. So I'm saying past days in consideration. I'm taking 60 days in consideration as of now. Okay, and now we are working with the split of data. See guys, for I and range of past days in consideration to the length of train data. Okay, perfect. Now just have a look guys, and let's try to understand what I'm trying to say. Okay, we have not defined train and test over here. That means X train and Y train. So X train, Y train equals to blank and blank. Okay, it is an empty list right now. So X train dot append. Okay, and have a look guys what I'm doing. Train data. Okay, I minus, okay, past days in consideration. Okay, past days in consideration. Perfect. I think it should not be I minus 60. We have to start from 60 and we'll be going till I. Okay, yeah, I minus past days in consideration till I, and over here I want the zeroth column. Now tell me everyone what you are understanding from over here firstly. Everybody, I want you all to give me an understanding from over here, then we'll proceed forward. If you guys want, let me write it over here somewhere so that you guys can easily understand. So we'll start from 60, right? I'm repeating there, no need to worry. See everybody. What's the first value in I? It will start from 60, right? 60 minus 60 is what, everybody? 0. I value is 60 over here, right? We are starting from 60. Past days in consideration, we have taken 60 days. So I put 60 days over here. See, 60 minus past days in consideration, this is 60. Till I, that means till 60, right? And then use the column 0th, that means the first column. If I run this code, guys, check it out. Haven't I got 60 values, 60 days values? Everybody, is my understanding correct? Do let me know this, please. Right? So what I'm trying to make is, guys, we'll have multiple sequences that will have 60 values each. And each of these 60 values will help us predict the next value. Okay. So am I not creating a batch, guys? Am I not creating a sequence data over here? Everybody do let me know. Am I not creating a sequential batch over here? Right? Exactly, that is what is written. It is written 0, 60, comma 0. Simple as that, guys. Everybody, have a look. I have just written train data, okay, 0 to 60, comma 0. That's it, what I have written. Next time when the loop will run, it will be 61 minus this one, past data in consideration. So won't it be 1 to 61, guys? Is my understanding correct? One more 60 data sequence, right? Correct. Then again, let's check it out. It will be starting from 2 to 62, right? For the next part. Then again, 3 to 62, 63 actually, right? So 0.0 correspond to the first 60 rows of the first column. Exactly, dear. Exactly. Very good. This one, the 60 values of the start. Okay. Then it will remove this value. It will work with the next 60 values. It will remove this value. Will work with the next 60 values. So aren't we having a sequence, a batch of 60, 60, 60, 60 each time, guys? Everybody do let me know this, please. Right? Exactly. Moving in an interval. Very good, Yash. Is everybody clear with how exactly you're making the data? Everybody, right? But you can choose anything there. Okay, I'm just taken 60 days. You can take 30 also. That's entirely upon you. Okay. For predicting one value, I'm taking 60 days in consideration. You can take 45. That's entirely your personal choice. Okay. Because see, that's the stock data, right? So I'm taking like the 2 months record at the same time to read the next record. Okay. Hide out the number of rows in the multiple 60. No, 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 no. No, no, not like that. You can take any values. Okay. Can we use train test split for model training? You can do that, but I think this will be a more effective way in running because we are making manually our testing set. If you go with the train test split, it will give you just the 2D arrays. You won't be having, I think, the batch inputs over there. Okay, the sequential input. But you, obviously, you can give it a try. That's completely fine. You can give it a try then. Perfect. So if that is done, let's go with the Y train also. So in Y train, we don't need the particularly the all the values. So I need to just append from what I need to append here. I think we'll use a train data again. Train data will start from I to 0. That's it. Okay. Only those particular values we are appending. Okay. 60, then next particular index, that is 61, 62, 63, 64. Like that. We'll be just appending that. So for training purposes. We won't be having a batch over here. We'll be just having some few particular values with us. Because that's our training data, obviously. Yeah. So we don't need this. We are just using it for training purposes. So we need to have this value because see, this value will give us 60 values, everybody, right? This value gave us 60 values. Now, obviously, using this record from 0 to 59, right, everybody? Tell me, everybody. Using this record from 0 to 59 in a hinge, aren't we trying to predict 60? Is my understanding correct? Everybody, do let me know this. Leave the code part right now. Just focus on this statement, correct? So, am I not writing over here that starting from 0 to, okay, 60 in the column 0, that means this part will be skipped, so we'll have the records from 0 to 59. And then am I not saying over here that in the train data in your Y train just append the 60? So aren't we using this 60 records to predict the 60th index value? Everybody, is my understanding correct now? Let me know this, please, everyone. Is everyone with me on the same page? Right? Sare? Chalo. Let's move forward and remove this part. We've got our training data now. Okay, and obviously we'll have to like reshape it and we'll have to convert it into an array format so that we can use it. Okay, so that's the next part. So converting into array and reshaping. Okay, converting into array and reshaping. Okay, because and why we are reshaping, guys, can you please let me know, everyone, why we are reshaping this? Array creation is understandable. Why we are reshaping it? Anyone who can give me an idea? Tell me, think of it, guys, everyone. Why we are reshaping it? Why we are reshaping the X train firstly? Because Y train we don't reshape. Why we are reshaping X train, everyone? NP dot reshape. Okay. I want to reshape X train 1D, 2D. Okay. Not together. Exactly, guys. Because the model expects a 2D data, everyone. Whenever you're passing your X data, the model expects it to be in 2D format. Okay. So I'm giving X train dot shape 0. Let me check the shape. I think I have not checked the shape even. X train dot shape. What's the shape currently? Uh, okay, it's 231 to 60, right? So it will give us 2D data expected. Exactly, very good. Okay. So I'm just reshaping it in the proper format. Already it's in the shape, but just for confirmation sake, we are also doing it once again. Perfect. X train now ready. And we need basically something. Let me check it now. Should be 28, 60, and 1. Perfect. A 3D part. Okay. So now we are having a data that is actually in the batches of this one, 62 one. That's perfect now. Clear? Chalo. Now let's work on our LSTM net really quick. Okay. Oh, a lot of steps we have done. 1, 2, 3, 4, 5, 6. Oh, a lot of steps actually. Chalo, let's be quick. Step 11, working with LSTM. Okay. So we'll be really quick over here, where I won't be wasting time. So I'm going to train a net of we'll have two dense layers and two LSTM layers, guys. Okay. So two LSTM layers. Okay. Or you can say units, that will be more precise. So two LSTM units. So that's the case over here. And two output units. Okay, two output units in total. Okay. So this is structure of the train net. Okay. Structure of the train network. Okay. So model equals to, it is a sequential. And in this model, I'm going to add a layer that is our LSTM. Okay. Sorry, add LSTM. Now, how many neurons we want to have, everybody? Over here, how many units should we take? I think we can take 128. One? No, I think one will be very less because we are having a lot of data, Shivani. Let's take a bigger one. Okay, let's try something bigger. 128. What do you say, everyone? Perfect. Eh? We'll have two units of LSTM. In one of them, we'll have 128 neurons, and in the second of the part, we'll have like 64. Let's keep it 64. So the calculation that I am doing, just because you know everyone that for choosing up the neurons, there is no particular maths, right? Is everyone aware about that or not? Please let me know. Guys, are you guys aware that there is no particular maths behind choosing the number of neurons, everyone? Okay. There's no not like okay, this is the number of units that you should take. This is the number of the memory units that you should take, right? You can take anything over here. Literally, like you can take anything. There's no particular restriction to that. It should be in the power of 2 for easy. Exactly. It should be in the power of 2 to be easy. Okay. Then also over here, I'm saying return sequence equals to true. Now, what this return sequence will do, guys, have a look to it. This return sequence will return the entire output for the next layer to process the information across the time. Okay. And in what format we will be passing. Okay. That means the next particular input, right? What exactly is the shape that it is expecting over, right? So that is what we need to pass in the next part. So I'm going to say input shape. Okay. What is the next shape for the input? So I'm going to say X train dot shape. It will be 1 to 1. Okay, that means 60 to 1. The next particular layer will also receive the input in the 60 to 1 format. Then I'll add one more LSTM layer over here that will have 64 memory units to process. And here we'll say return sequence equals to false because we are not returning anything to the next layer. Okay, because next layer is going to be the output layer, so it will automatically take care of that stuffs. Perfect. Anyone having any doubts till this point of time? That in these two layers? Do let me know if you guys are having doubts. I can explain this out. There is no issue with that. Clear? See, if you guys won't say anything dear, I'll just move forward. Okay. Please repeat. Okay, sure. So see, dear, the first thing is, I think the first line is very much clear to you that that's a sequential model that we're training. In the second layer, if you might notice, there's a LSTM unit that is having 128 memory units. That means 2 to the power of 7. Okay. We are having 2 to the power of 7 memory units. And then if you notice around the return sequence, this particular parameter is used when you want to return the entire output to the next layer. Okay, because see, we are having two layers over here, right? There's one LSTM layer, there's second LSTM layer. So the output from the first LSTM layer will be the input to the second one, right? So we need to specify that if we want to pass the input or not, right? And in what format we want to pass, in what shape we want to pass, that is what we have mentioned over there, that okay, in this shape your input will go in. Okay, and we have mentioned one over there because right now we are using a single variate, right? We are having only single variable that we are trying to predict. Correct. Then if you see the second LSTM layer, it has 64 memory units, and this layer only returns the final output. Okay, so we don't need to put anything. If it would have been like we would have one more LSTM layer, so we would have mentioned the same thing, like what would be the input parameters, what will it return a sequence or not. But right now this output will be directly returned to a dense layer, so we don't need anything, right? Then if I go ahead, I'm going to add a dense layer, guys. Have a look, everyone. Model.add dense, right? And this dense layer is going to have 30 memory units. Okay, and then we'll also add one more dense layer that will only have one memory unit. Perfect. Sure. Let's run it and let me explain you. So over here, why I have taken 30? Again, no magic numbers. 30 basically I have taken because it will basically convert, okay, everything that we are having to a lower dimension. Okay, this layer will transform your output from the LSTM layer, that is you are having the LSTM part, to a lower dimension that is of 30 features. And then the next layer that will take all of the output from the like the previous dense layer and will create a final output in one particular neuron. So generally, whenever we are doing a regression, because as you guys are aware, any time series part or any particular thing is just a regression. We are trying to predict something over here. So we need only one particular neuron that will be outputting our final result, and that particular neuron will be one. If it would have been a classification problem, I would have taken that much number of classes, that much number of neuron to represent each and every class. Okay, so this is how exactly this net has been trained, everyone. Okay, it is saying return sequence is not understood. We took 30 as almost the half. You can take anyone, dear. Okay, there's no issue with that. You can take anyone, as I said earlier. Let me see. I think I have made a mistake. Yep, correct. So basically, let me explain you the architecture once again. Input goes 128 neurons over here working, right? They'll be producing some results, and the results will be passed down towards the next LSTM layer that is having 64 memory units. Now the 64 memory units are going to process the result and going to produce an end result that will be passed down towards the dense layer, having 30 neural units. Now this particular results will be now reduced in the dimensions to 30 dimensions, right? And then the last output will be transferred to this last dense layer over here, okay, and will give us the final result. Is this clear to all, everyone? Again, this is entirely customizable. If you want, you can build like 3 or 4 LSTM units with 64, 32, 32, 20, or like that. That is also possible. There's no issue with that. I've taken a bigger one so that we can consolidate the code at once only. Okay. And you can take anything. If you want to go with one, you can go with one. But again, that will actually compromise maybe your training part. So you can also look onto that once. Again, let me ask it. Is everybody clear? Akhil, dear, are you clear with this? Do let me know now. Are you clear with how exactly this thing is working? Sure. Now, if everybody is clear, let's go ahead with the compilation part. Okay, let's compile this results really quick. Compiling Okay, I think guys we'll take like 2-3 minutes more for the session. So sorry for that. I'll be extending it for like 2-3 minutes more so that I can complete it. Okay. Model dot compile, and we want to compile it on the basis of Adam optimizer. So optimizer equals to Adam, and the loss that we are going to take, since this is a problem of regression, so we can take mean squared error over here, and that's perfectly fine. That seems perfectly good. Let's go ahead. Let's compile this and let's now use the prediction, or let's firstly fit the data. Fitting the data over here. So model.fit. We want to fit our X train. We want to fit our Y train. Okay. And we want to take the batch size, one batch at once. And for right now, I'm taking small epochs because again, if you'll take high epochs, it will take a very lot of time to get trained. So only two epochs as of now. What is Adam? Adam is a optimizer, Akhil. I think Adam optimizer you might have like already read, if I'm not wrong. Have you guys heard about the Adam? Everyone, I think you guys might have heard about in the neural network series only when you guys were working with the AI part, right? So it's basically a iterative optimization algorithm, guys. Okay, it's like a kind of like, have you guys heard about this gradient descent part, right? Exactly, it's a gradient descent technique that helps you to optimize. Okay, the name is adaptive moment estimation, if I'm not wrong. You can just search for it on the internet. So basically, the Adam is kind of extension to the stochastic gradient descent. Okay, and it is very much adopted in the part of the neural networks because it works very similar to SGD, and it helps us to minimize the error actually. Right. So now let's fit the data really quick. Going ahead, fitting it out. So epoch number one going ahead. That's going to take time actually because we are not on GPU. No, we are not on GPU. So it is going to take time, I guess. So 2741. Okay, I think it will take around 2 minutes to get trained. Okay, and if it case guys, if you want to accelerate your tasks, everyone, so use GPUs and that will accelerate quite quickly. I think it will be done nearly in like a minute or two if it is GPU. So it would have been done till this point of time. Okay, need to go GPU. Really quick there. See, if you guys are working with the collab, right, you have an option to switch. See, change just runtime, T4 GPU, save. I'm now connecting to GPU. Might notice on my on the portion, it's written connecting to GPU. Okay, 3 to 1, it's connected. Let's run it on. And see the difference in the running time, guys. That's why the GPUs are highly recommended nowadays. Okay. See, if I run it out, see the time it will take for training and each and every step. It will just take minimal as time possible. I think above code would have been complete till this point in time. It's loading. Okay, it's loading the libraries now. Keras done. Everything done over here. Done. Done. We're also done. Done. Yeah, this is also done. I think it's on the part of training. See, epochs. Consider timing for training, guys. It will be very like I think 5 times faster than what you have seen right now. Okay. So 3, 2, 1. I think the training will start now, if I'm not wrong. Should it start by now? And the timing for the training will be very less if you're using GPUs. Okay, see, 46 seconds only. And I think you might notice a change in the time of execution also. Can you notice that? Notice a change, guys? The speed, everybody, as compared to the CPUs. Can you notice how the change that is happening? Right? It's quite faster, right? It's very fast than a normal conventional CPU. Okay. We're training the epochs. I think the loss seems to me very less, 0.0. So that's fine. The loss is good. Uh, that's good. Chalo. Till the time it is getting ahead, let's create our testing data also because we need that also. We have not created our testing data. Testing data creation. Even Jupyter, we can use GPU. Yeah, you can use GPU, Shashank, but in that you will have to configure your particular laptop's GPU or your system's GPU, and then you can work upon it. And that's a time-taking process. You will have to go with a lot of stuff like CUDA and all that. My recommendation is use Google Colab for the same. Okay. I'm creating my testing data over here, guys. So I'm just giving train length minus 60. That's it. Okay, we are done. This is our train data, and we also need to create the subset. So creating the subset of testing data, that is your x train and y train, x test. This will be our part of data that will be used for part testing. This is our y test. It will have df close dot values from train length, after train length to eternity. This is our testing data, guys. We have prepared a testing data over here saying testing data values. Okay, I think it will be values if I'm not wrong. Perfect. Sure. Again, we'll have to convert it into array. We should have done it already. Okay, converting into array. We should have already done this like in the previous step only. I think why I have not done this, I don't know. I might have forgotten. The same process actually, nothing changed as such. So let me copy it from over here actually. Just instead of working with this, we will do it just for the X test part over here. And actually, because in Y test, I am already having the values. I've already fed the values in the Y test. So we don't need the X test. And append, this will have test data over here. And the length of train data. The length of train data. And sorry, test data. Okay. 60 length of test data, everything seems fine. I minus 60. I have to convert the sequence over here as well. I'll be a little bit quick over here, guys. If in case if you're having difficulty, it's the same code that we have written earlier. I'm just trying to map everything with respect to the X test over here. And again, we need to create and reshape. So let me copy this whole stuff. So copy